The essential question for this unit is, in what ways can matter change? There are three main ways in which matter can change. One is physical, one is chemical. Those are both found in chapter 21, section 3 of your book. And the third is nuclear, found in chapters 19 and 20 of your book. We already talked a lot about nuclear reactions in Objective 3 of our first unit, describe and give examples of nuclear reactions, so I'm not going to focus on that one here because I assume you already know it. Instead, I'm going to focus on physical and chemical changes. There are some important ways in which physical and chemical changes together are different from nuclear changes, and I'll talk about that later in the unit when we get there. So a physical change is a change that does not change the way atoms in a substance are bonded to each other. Another way of saying that is it's a change that does not change the chemical structure of a compound or molecule. Let me give you an example of that. An example is ice melting into water. It's solid H2O changing into liquid H2O. As you may remember from your middle school days, the only thing that's different about this is how the H2O molecules are organized in relation to one another. But whether it's solid or liquid, it's all H2O. The chemical structure of the water hasn't changed. Just the distance the water molecules are from each other has changed. That's a physical change. Another example would be mixing two pure substances together that do not react. So for example, mixing table salt, NaCl, into water, H2O, gives you salt mixed with water, not some brand new substance. The Nas don't react with the Os, the Cls don't react with the Hs, nothing like that happens. You get salt mixed with water. It's important to know on this, and I'm assuming you already know, again from your middle school days, what a pure substance is. A pure substance could be a pure compound, such as NaCl or H2O. It could also be a pure element, such as gold, for example, would be a pure element. This goes back to the first question on your last test about how small can something get before it's no longer that thing. And of course the answer was both students are correct. If you're talking about something, an element like gold, the smallest you could get would be 1 atom of gold, still has the properties of gold. If you're talking, on the other hand, about a compound such as NaCl, salt, the smallest it can get is NaCl before it's no longer salt, before it becomes something else. So now let's look at a chemical change. A chemical change is a change that does change the structure of compounds or molecules. So it's the reverse of a physical change. Another way of saying that is it's a change that does change how atoms are bonded to one another. So let's look at an example. We're going to look at changing water into hydrogen gas and oxygen gas. So let me draw for you how that would look. We know that water is H2O. Hopefully you remember its structure is like this. If we run an electric current through water, we can actually get the bonds to break and get them to reform as hydrogen gas and oxygen gas. So we can draw a little arrow. And then we would get O, and if you remember, it's double bonded. And we also get H's, hydrogen gas, bonded to each other. Some of you might notice that somehow we got 2 O's, even though there was only 1 O in the water. That has to do with what's called the law of conservation of mass, and we will talk about that later in the unit, but that's a good observation. As you can see, though, the H's are no longer bonded to the O's. They're two completely different substances. They're oxygen gas and hydrogen gas, which are not at all like water. That is a chemical change. Another example of that is if you breathe in oxygen gas from the atmosphere, there's some sort of change, and we're not going to go into the details of it, but it happens within your respiratory and circulatory systems, and you breathe out carbon dioxide. So there is a chemical change that the oxygen goes through. It combines with some carbon, obviously, that doesn't come from nowhere, and you end up with carbon dioxide in the end. The oxygen has changed into something new. Please be really careful of using any tricks you learned in middle school. I know some of you learned that chemical changes are not reversible, whereas physical changes are reversible. That doesn't necessarily always hold true. For example, if I cut my hair, that's not reversible without more hair growing, yet it's a physical change. And yet I can breathe in oxygen gas and breathe out carbon dioxide. A plant can reverse that by taking in the carbon dioxide and giving off the oxygen. So that, in a sense, appears reversible. So be really careful of any tricks that you've learned. The real key is, does the structure of compounds or molecules change? Does the way in which atoms are bonded to one another change? And that's what's going to get you to whether it's chemical or physical.